In today's video, I'm going to be showing you how to get the derivatives of different functions. Make sure you pay close attention because I will be making the questions relatively easy. We have different types of functions. We have the polynomial functions or our algebraic functions. We have the exponential functions, the logarithmic functions, the trigonometric functions, and there are other types also. So let's begin with the algebraic functions. Y is equal to 4x raised to the power of 4 plus 3x cubed minus 3 over 2x squared. How do we get the derivative of this? We pick them one by one. Let's pick 4x raised to the power of 4. To get the derivative of this, we multiply the power by the coefficient. So we would have x, 16x. We subtract 1 from the power. 1 subtracted from 4 is 3. So we have 16 cubed. So the y dx, don't forget to include this. The y dx is equal to 16x cubed plus power multiplied by the coefficient. We have 9. 1 subtracted from the power, we have 2. Power multiplied by the coefficient again, 2 multiplied by 3 over 2 is 3. 1 subtracted from 2, we have 1. So this is the derivative of these algebraic functions. Let's move to another function. Let's move to the exponential functions. We have y equal to exponential 3x over 2. This is our exponential function. Don't make this. This is not equal to this. This is our natural logarithm. This is the exponential function. So this, to get the derivative of this exponential function, the first thing we're going to do is to get the derivative of its power. The derivative of its power. Let me put it in this way. Let's say we have this. The y dx would be the derivative of x plus dx. This is what I meant. Okay, let me show that to you. So we have y equals the y dx is equal to the derivative of this is 3x plus 2. The derivative of 3x plus 2 is 3. Wait, I think I wrote the wrong thing. I don't know. But let me put that down again. If we have y is equal to this, the derivative of this, the y dx, would be the derivative of this multiplied by this. So let's do that here. So we have the y dx equal to the derivative of this. The derivative of 3x plus 2 is 3. You should know how to get that. Multiplied by everything here. E raised to the power of 3x plus 2. So this is the derivative of that function. Let's take on that question. To get the derivative of this, we get the derivative of this first of all. The y dx is equal to the derivative of cos s is minus sine x. Then you write everything here. E of s. So this is the derivative of this function. Let's move to the logarithmic functions. Why is this not leaving? Alright, let's say we have y equal to log to the base of e 4x cubed plus 5x squared plus 3. Know that this is natural logarithm. Log a to the base of e. This time our a is this. Is the same thing as ln, also the natural logarithm of a. So we can rewrite this in this form. y is equal to ln of 4x cubed plus 5x squared plus 3. Whichever way you write it, they are both correct. So the derivative of this, the y dx, is equal to, what we're going to do is that we take the derivative of this, we make it the numerator, then this would be our denominator. So let's write down the denominator first of all. 4x cubed plus 5x squared plus 3 first of all. Then we get the derivative of this and make it the numerator. The derivative of this, try that out. You can pause the video and try that out to see if you fully understand how to differentiate the algebraic functions. So this is 12x squared plus 10x. The derivative of 3 is 0. This is the derivative of this function. Let's move to the trigonometric functions. Let's say we have y equal to tan of 3x. How do we get the derivative of this? Normally, the derivative of tan x is what? Is sec squared x. What about the derivative of tan ax? Let's say x has a coefficient. Then the derivative would be a, that coefficient, then sec square ax. So let me erase this. So the derivative of this trigonometric function is this. We pick the coefficient 3, then sec squared 3x. This is the derivative of this function. What if you're told to use chain rule or something like that? The derivative of this should be, first of all, you get the derivative of the angle in front of the tangent. The angle in front of this tangent is 3x. So the derivative of 3x is what? 3. And we multiply it by we get the derivative of tan. The derivative of tan, whatsoever angle, is sec squared that angle. So we multiply it by sec squared this angle, 3x. Still the same thing. So let's try out another trigonometric function. Y is equal to cosec 5x. Derivative of cosec ax is equal to minus a cosec as cot ax. So this means that derivative of cosec 5x would be minus 5 cosec 5x cot 5x. If we were to use chains rule, we get the derivative of this, which is 5, multiplied by the derivative of cosec whatsoever angle is equal to minus cosec that angle multiplied by cot that angle. So this would be minus cosec that angle multiplied by cot that angle, which is the same thing. So whichever you remember, just pick the one that works for you, or what the question. Some questions will tell you that use this method, use this method. Maybe your teacher might tell you, okay, use chain rule. Your teacher might tell you use first principle. So it depends on the question also. Let's take this other function. This is like a constant. Let's say y is equal to k to x plus 1. Notice that this is not the exponential. This is like a constant, an ordinary constant. How do we get the derivative of this? Also similar to that of the exponential, we get the derivative of this first. The derivative of 2x plus 1 is 2. Multiplied by, we also write down the question again. Then we multiply it by the length of the constant. The constant here is k. So our answer would be 2k 2x plus 1 ln k. This, how do we get the derivative of this now? So the derivative of this will be dy dx is equal to, get the derivative of this. The derivative of cos 3x. Try to do this. What is the derivative of cos 3x? That would be minus 3 sine 3x multiplied by 4 cos 3x. That is everything here, multiplied by the length of